Welcome to this particular module, and here we will understand a very important step that is used in fabricating lot of devices. Alright. So, what is that particular step or process? That process is called photolithography. Now, until now what we have seen is how can we select a substrate, and if we select silicon as a substrate, then how can we grow oxide, and once we grow oxide, then how can we deposit metal or insulator or semiconductor. Now, if I want to pattern this semiconductor or insulator or metal, I have to understand what is photolithography. Now, your question should be that where I will use photolithography. So, when you design a MOSFET, you have to design source and drain, right. So, you want to diffuse the N type dopant or P type dopant only in the area where you want to have your source and drain. Then you have to grow oxide only below the gate, that is a thin gate oxide, right. Then finally, you have metals, so you have to deposit the metal and pattern these metals. So, require creating a window for diffusion, creating a thin layer of oxide and patterning it, creating a polysilicon gate or a metal gate, and creating a contact pads with metal. This all requires photolithography. All right. So, if you understand photolithography, then you can understand lot of steps, lot of devices, not only MOSFET, but also the whole circuit design and also lot of other engineering devices, this which can be sensors, which can be actuators. These are all micro engineered devices. All right. So, let us understand in this particular module what is photolithography. So, if you come on the screen, this will be our class 7, and when I talk about photolithography, right, the word itself has 3 different subgroup, photo or 3 different words, photo, litho and graphy. All right. So, this lithograph is again we have seen in the class 1 that it comes from a word lithos, right, and graphic, that means that we are carving a single stone or we are carving a stone, right. It is a monolithic single stone, but litho is carving, graphic. Okay. So, using photons, so photolithography, right. Now, nothing but purpose of photolithography is to create small structures or features, on a silicon wafer using photoresist. So, we should understand what is photoresist, right. Features made out of photoresist by etching with UV light. So, understand how we can expose the wafer with UV light, So, 2 things we understand is, one is you can create small structures, second is you have to use photoresist, third is you have to expose or etch this photoresist with the help of UV light. You have to pattern this photoresist with the help of UV light. 3 things we understand. Okay. So, what are the steps in photolithography, right? What are the steps in photolithography? The first step is you have to clean your wafer. That is the first step. Always when we start fabricating a device, the first step is you have to clean your wafer. Second is you have to coat the wafer. Coat the wafer with what? Photoresist. That is called photoresist coating. All right. So, for photoresist coating, what are the steps? First step is you have to pre-bake and primer coating, pre-bake and primer coating. All right. That means you have to coat the photoresist. So, before photoresist, the primer coating is, sometimes you will see a word called HMDS. HMDS. This is your primer. All right. So, for improving the adhesion of photoresist onto the oxidized silicon substrate or onto the metal over the oxidized silicon substrate, sometimes we use a primer called HMDS. All right. So, first step is your pre-bake and primer coating. Second is photoresist spinning. Photoresist spinning. So, this is first step, this is second step. Third step is soft bake. Soft bake. Now, you should know these things we have already discussed, right. One is spin coating. After spin coating, you have to do soft bake. Soft bake or pre-bake. Remember this word pre-bake? The pre-bake was done at 90 degree centigrade, right. Pre-bake was done at 90 degree centigrade for 1 minute using hot plate, using hot plate. This we have discussed when we were looking at the fabrication of interdigitated electrodes in SU8 Remember this word pre-bake, right. Pre-bake, pre-bake is also called soft bake, pre-bake is also called soft bake. All right. So, first is your first thing is you have to pre-bake the wafer, pre-bake the wafer, because you have cleaned the wafer using chemicals, and then finally you rinse the wafer using deionized water, and that is why you have to dry the wafer, you have to dehydrate the wafer, that you can do with pre-baking, and then you have to do primer coating. So, then from now we will use to distinguish the pre-baking, that is pre-baking is used for removing any water content, right, on any moisture content, pre-baking we will use, and we will use soft bake when it comes to photoresist. So, it is easy for us to identify or delineate between two. All right. So, we will use soft bake when it comes to photoresist, we use pre-bake whenever it comes to removing the moisture from the surface of the wafer. Okay. Now, so the step for PR coating would be first step pre-bake and primer coating, second step photoresist spin coating, third step soft bake. Then you, if you remember, I have shown you masks. Masks. What are type of mask? Bright field mask and dark field mask. Bright field mask and dark field mask. Using the mask, we have to align the wafer and expose the wafer, right. Expose the wafer which is already spin coated with photoresist and has been soft baked, That wafer we have to align it and we have to expose it. Aligning will be done using the mask. Mask are two types, one is bright field, second one is dark field, right. And then exposure is done using UV. UV is your ultraviolet light. Easy. So, first thing is wafer cleaning, second thing is primer coating. Before primer coating, pre-bake, then primer coating. After primer coating, PR coating. PR coating is photoresist coating. After that, you have to do soft bake. Soft bake is done at 90 degree centigrade for 1 minute if you keep the wafer on the hot plate. If you keep the wafer inside the oven, then the time would be higher. Okay. So, after soft bake is done, you have to expose the wafer, but you can do exposure with the help of a mask and UV light. You have to keep the mask on the wafer which is coated with the help of photoresist, right. That alignment is done with the mask and then it is exposed using UV light. We have seen this, if you remember. If you do not remember, again look at the video where I have taught how to pattern interdigitated electrodes inside the SU8 well, or how to fabricate a gas sensor using microfabrication techniques, and you will understand that how we are using the photoresist. Okay. So, I will also show you one time again in this particular lecture how we can use photoresist, how the exposure is done, how the alignment is done. Alright. So, we come back to the screen and what we see is the next step after alignment and exposure would be development. Development of what? Development of photoresist, development of photoresist. So, next step would be so this is your fourth step. Fifth step would be developing photoresist. For developing photoresist, you have photoresist developer. You have photoresist developer. Alright. After you develop the photoresist, you have to perform a process called hard bake, right. One is soft bake, one is hard bake. Hard bake is carried out at, you remember, right, 120 degree centigrade for 1 minute on hot plate. 120 degree centigrade for 1 minute on hot plate. After hard baking, you have to inspect the wafer. You have to inspect the wafer. We inspect the wafer for what? Whether the photoresist has been properly patterned or not. Whether the photoresist has been properly patterned or not. This is very important. Alright. So, for performing that, for performing this hard bake and to understand whether the photoresist is properly patterned or not, what we will do? We will see what are the steps and what do you mean by wafer inspection. What do you mean by wafer inspection? Okay. So, let us see on the screen. If you see on the screen, what do you see? A blank screen. Now, let us take an example. Okay. Let us take an example, whatever we have seen. What we have seen? We have seen the following steps. We have seen the following steps. So, what I want to show is what do you mean by pattern inspection and how can you inspect a pattern. So, let us see. So, let us assume like this, that we want to pattern a metal with this particular shape, and this shape is your meander shape. Okay, meander shape. Like this. All right. So, what you want to do? You want to have a pattern of metal which will look on this, when we look on the substrate, it looks like this. So, what is this material? The material is a photoresist. So, I want to see whether I can pattern this photoresist, on the silicon substrate, okay, and whether it looks like this or not, and how can I obtain this pattern? That is another question, right. So, we will obtain this pattern with the process that we have just now seen, a process called your lithography, photolithography, because we are using UV light, right. So, let us see what is the first step. First step would be we take a silicon wafer. Once you take the silicon wafer, then what you do? You have to grow a oxide, because this pattern we want on the oxidized silicon wafer. We want this pattern on the oxidized silicon wafer. All right, guys. It's very easy. All right, I want to see this pattern. I'll make it a little bit thick, and maybe one more layer. My pen is not working properly, right. That is why you see that there is lot of error. Amazing. Anyway, doesn't matter. Point is not to drop it correctly, just okay. So, now I want this pattern. All right. So, what will I do? First I will, you see on the screen, first I will take a silicon wafer. Next I will grow a oxide. next I will grow oxide. Now all of you know how to grow oxide, right? All of you know how to grow oxide using thermal oxidation, using thermal oxidation. So, I am growing SiO2, this is my silicon, this is my SiO2. Now, I want to have a pattern of photoresist which looks like this, right. So, what will be the next step? Next step would be I will deposit or I will spin coat the photoresist, on the oxidized silicon substrate, right. That will be my third step. First step is I take a silicon wafer, then of course, when I do not say that we are cleaning it, we have to assume it we have cleaned it. Okay. You take the silicon wafer, then you clean it, rinse it with a DI, then you pre-bake it, then you apply a primer, then you grow oxide, then you coat, spin coat, photoresist, alright. This process we have done, that is why we have from here we have obtained which is wafer shown here, alright. What is our next step? Next step is if you remember, right, next step will be our soft bake, right. If you go back, see, we have done this, now we have to do next, which is soft bake. So, we will keep this wafer on a hot plate at 90 degree centigrade for 1 minute, and this is a positive photoresist, okay, that we will discuss. We have discussed, we will again discuss, this is photoresist and is a positive photoresist. So, we will put this wafer on a hot plate at 90 degree centigrade, for 1 minute, alright. That is our soft bake. Now, what is the next step? Next step, we require a mask. So, we will have a mask that will have a pattern, which we want, which is shown here, alright. I am just showing this representative diagram. So, it looks similar to it, okay, it looks similar to it. So, do not say that there are four square waves and I can only see 3 here, that is not correct, it is a representative diagram, okay. So, you have a mask with this particular pattern, and we have discussed that this mask where the pattern is dark, and the field is bright, when the pattern is dark and the field is bright, is called bright field mask, right. This is called, see, the field is bright, this is all the area here is bright. So, it is a bright field mask, right. Now, once you have this mask, what is the next step? Next step is we will load this mask. So, next step would be we will load this mask. So, I will draw the wafer once again, then we have oxide, then we have photoresist, right, and then we have done soft baking already, we have completed soft baking. So, what is the next step? Next step is we have to load the mask. Load the mask where? Load the mask on this wafer. That means, I will load the mask, which has pattern, this is a cross section, right. You see this mask, okay. I am loading this mask, let us say M1, this is my photoresist, this is my silicon dioxide, this is silicon, this is silicon dioxide, and this is my cross section of the mask, right. So, if I take a cross section or side view of the mask shown on the bottom left of the screen, then it will look something similar to what I am drawing here on the wafer. So, now I have loaded the mask, now I have loaded the bright field mask on the oxidized silicon substrate. What is the next step? You have to align it. So, I have aligned it. Next step, you have to expose it. Expose using what? You know, expose using UV light. Expose using UV light. What is UV? Ultraviolet light, right. So, let us go back. So, we have done pre-bake, primer coating, yes, I said okay, let us consider primer coating is done. Next is photoresist spin coating done, soft bake done, alignment and exposure done. Next is development. Development of what? Development of photoresist. So, for developing photoresist, the first step would be that you have to take out the mask, you have to unload the mask, you have to unload. So, after this step, next step would be to unload the mask from the photoresist and dip this wafer, dip the above wafer in photoresist developer, When you do that, right, now you understand, okay, very important. We have used positive photoresist. So, whatever the pattern, suppose this is the pattern, then we will have, or let us say, let us put a symbol, so it is easy. Let us say this is the pattern Z, alright. Then if I use positive photoresist, I will get Z, okay, same pattern. That means, whatever area is not exposed, you see if I expose this, right, then the area which is Z, that area is not exposed. The area which is not exposed, that area becomes stronger. The area which is exposed, that becomes weaker. So, in this particular case, the area which was not exposed, the area under this pattern what was not exposed, and what is the characteristic of positive photoresist? The area which is not exposed gets stronger. The area which is not exposed gets stronger. So, when I dip the above wafer in the photoresist developer, what will happen? This will happen. What will happen? This thing will happen. You see here. This is my photoresist, right. So, this thing will happen when I dip the above wafer, this particular wafer in the photoresist developer, alright guys. And then I have to see whether my photoresist is completely developed or not, is perfectly developed or not. That is called wafer inspection. So, if you go back, I have done what I have done. I have now aligned an exposure, pre-bake and primer coating, photoresist spin coating we have done soft bake, then we have done alignment and exposure, right. Then we have developed the photoresist, and then we have done hard bake, right. So, we have to next step is, after developing the photoresist, we have to put the put the wafer at 120 degree for 1 minute on hot plate, right. That is your post bake, or hard bake. Finally, you have to inspect the wafer, you have to inspect the pattern. So, what is a pattern? Pattern is this particular pattern. In our case, we will inspect once this is done. This is what it means when we are talking about photolithography steps, which are shown right over here. All right, easy, extremely easy. I will take an example, another example, so you get it. Okay. So, you have to understand, when you have to develop or you have to pattern something, these are the steps that you have to follow. So, after this, let us see how the wafer is clean and how the pre-bake is done. How the wafer is clean and how the pre-bake is done, right. So, the wafer can be cleaned, that is the silicon wafer can be cleaned by several techniques. One is bubble jet, where you have to use nitrogen plus water, right, in a jet formation, and you can use bubbler. So, you can clean the wafer. Second is, with high pressure you can rinse the wafer. Third is, you can use a sonicator and clean the wafer. Sonicator is used at 1.5 megahertz, and these are the cleaning techniques for silicon wafer. These are the cleaning techniques for silicon wafer. Now, there can be moisture on the wafer after you perform these steps, right. So, how to remove or how to dehydrate the wafer? For that, we have to do high temperature baking, also called pre-baking, to remove moisture after wafer cleaning process. Easy, very easy. Next, to improve the adhesion, I have told you, to improve the adhesion of photoresist onto the oxidized silicon or any material on oxidized silicon. You have to improve the adhesion of photoresist on any material that is deposited on the oxidized silicon, or you want to improve the photoresist on oxidized silicon. You have to first do the priming step, that is done by HMDS, and that is your hexamethyl disilicane, right, disilicane. So, hexamethyl disilicane is used for improving the adhesion of photoresist onto the substrate. That means that if I want to coat photoresist, I will first coat HMDS and then I will coat photoresist. If I want to coat photoresist on metal which is deposited on oxidized silicon, I will first coat HMDS, on that I will coat photoresist. So, it goes like this. Okay. Oxidized silicon substrate is the first one, second step is metal, third step is HMDS, fourth step is photoresist. In this case, oxidized silicon substrate first, HMDS second, photoresist third. Of course, you want to add further step, then A would be silicon. Here A would be silicon, right, easy. And this is, then you have to put it at 200 to 250 degree centigrade for about 60 seconds. There are various way of improving the adjusting or optimizing this temperature and time. There are various techniques to improve the various ways to improve the or optimize the time and the temperature, but that is we are not discussing. What we are discussing is that if you are given a wafer, can you clean the wafer? If yes, after cleaning, can you pre-bake the wafer? If yes, after that, can you coat HMDS on the wafer to improve the photoresist adhesion? Then it say yes, everything is yes, we can do this, yes, we can do this, yes, we can do this, right. So, this is your wafer cleaning and pre-bake technique, all right, easy, very easy, correct. So, if I let us go to the next topic. Next topic would be photoresist. So, what are the photoresists? Alright. We will see the photoresist in the next module, and so that you have some break in between modules. Right now what we have seen? We have seen how you can clean the wafer and how you can do the lithography step. For performing the lithography step, we have seen certain steps right from wafer cleaning, then you have to do pre baking and primer coating, then you do photoresist spin coating, then you have to do soft baking, then you have to align the mask, expose the wafer, then you have to do hard bake developing, then you have to do hard baking, then you have to do pattern inspection, then you follow with a example here, and then we have seen the wafer cleaning and the priming and dry dehydration steps. Now, the next step would be what are the photoresist and what are the kind of photoresist and how can we use photoresist for fabricating a or for using as a for patterning several metals or materials onto the oxidized silicon substrate, right. That will be the next step. So, I will see you in the next class. Until then, you take again a look on the things that we have discussed, and let us continue the next class how the photoresist or kind of photoresist are there and how we can use for obtaining a pattern of our desire. All right. I will see you in the next class. Till then, you take care.